everybody. So this is going through the Module A notes, the actual Module A notes. And I'm not going to go through every single item on here. There's quite a bit of information in the notes themselves. And when you look at the completed notes, I've put notes about how I did things and why. Tried to make it pretty self-explanatory. So what I'm going to do is I'm going to kind of spotlight a few things along the way. There'll probably be 2 or 3 videos worth of that for these notes because the notes are 22 pages. But then if you have more detailed questions about any of them, you can either email me or go on the Zoom office hours to let me know that you have some questions on that, okay? And just a reminder that the Zoom office hours schedule is always going to be on the to-do list for that week, which is in that yellow block toward the top of the Lumen page. Okay. All right, so talking about linear equations still here, and in the review section, we talked about solving linear equations. Here we're talking about systems of equations. So a system of equations is 2 or more equations that has the same values of x and y. So for example, this right here is called a system of equations because they're 2 equations, and when we solve them, whatever x is in the first equation, it's also going to be in the second, and same with y. So we're looking for an x and a y that make both of these true, okay? And we need to have 2 equations, so let me just quickly show you why that is. If we have one equation with one unknown, okay, I can solve this. This is obviously a very easy equation to solve, and in this case, y would have to equal 3. Now, if I have an equation that looks very similar, but has 2 unknowns, I can't solve that and say this has to be x and this has to be y. What I can do is come up with a whole bunch of options that would make it true. So for example, x could be 0 and y could be 8, or x could be 1 and y could be 7, or x could be 5 and y could be 3, okay? Or even, it doesn't have to all be integers. So we could have negatives also, which are integers. We could have negative 10 plus 18. We could also have negative, 1.5 plus 9.5. Right? We can have all different sets of numbers where this pair equals 8, but it could be any of these. And thinking back to graphing, this is the same as saying y equals negative x plus 8. We'll get into graphing a little more, but this would give us a line. Okay, so this would give us a line that would have all of these points on it. Every one of those points is a solution to that equation. So if I want to know, though, a specific x and y, then I need some other information also. So I might say, well, if x plus y equals 8, and I know that x plus 6 equals y, now, since there are 2 pieces of information, now I would have enough information for me to solve and figure out, in this case, only one x and one y makes this true. Now, the first thing we're going to talk about, the first method for solving systems of equations, is called substitution. And it works when we have an equation like this, where one of our equations is x or y equal to all of the other stuff. So this is saying y is the same as x plus 6. What that means is that I can plug x plus 6 in here where y is. So I can rewrite this equation substituting in this other expression. So x plus, now instead of y, I'm going to put x plus 6 because it's the same thing. And that equals y. Well, why is this good? Because now I have 2 things that I can add. So I have 2x. This is 8, not y. That makes more sense. 2x plus 6 equals 8. Subtract 6. 2x equals 2. Divide by 2. X equals 1. So there's my value for x. And then to find y, I can plug it back in. So I would say 1 plus 6 equals y. Well, that means y must equal 7. So there were all those different options of things that could add up to 8 before, but if I had 0 plus 8, for instance, they're not 6 apart. It wouldn't make this one true also. So x equals 1, y equals 7 is the only pair that makes that true. Okay, so that's the idea with solving systems of equations. Okay, so let me see. All right, so I'm trying to get myself back to my screen here. All right, so all right, there we go. So you can see my notes now again. So this, again, one of the ways we can solve a system of equations is by substitution. So we solve one of the equations for one of the variables. So x or y is by itself. This is one of the reasons why we did that solving for a variable at the end of the review section. Then we can, I said the right-hand side, in this case it was the left-hand side, but whatever the other part of the equation is, that can get substituted in for that variable in the other equation. So let's look down here for a minute. I have these two equations. Okay. Now this one's not quite as neat to solve for because when I solve for either the x or the y in either of these, I'm going to have to divide and I'm going to get a fraction somewhere. But I took this bottom equation, I got y by itself, so y equals -3/2 x minus 4. So now this part, this is what y equals, I can substitute this in for y in the other equation. So I rewrote this equation now over here. In place of y, I put -3/2 x minus 4. I had to put it in parentheses because 6 is getting multiplied by that whole thing. Distribute, solve this, right? This part right here is just like we did in the review section. Solve, get x equals -2. Then I plug that into either equation now. I just chose the bottom one, and that will give me y. In order to check it, you want to check that answer in both equations. I do not have the check written out here. You want to plug in x equals -2 and y equals -1 here. Make sure that you get a -4. Plug in x and y here. Make sure you get a -8. Okay. If you end up with an equation, or a system, I should say, where you end up with two things that can never be true, it means there are no solutions. Okay? It means just that there are no x and y that make both of these true. And then a second system, or second type of method for solving systems of equations is called elimination. Okay? So with elimination, what we want to do is we want to, again, get down to having an equation with just one unknown, because then we can do something with it. The way we do it here is we look at our equations and we want either the x's or the y's to cancel out when we add these two equations. So the way we're going to do that is by manipulating them a little bit so that either the x's or the y's have opposite coefficients. Opposites meaning like 5 and -5 or 30 and -30, because when the opposites add, they add to be 0. And those will cancel out. So if I look here, the common multiple of 2 and 5 is going to be 10, right? So I could make both of these into 10. I could make one into -10, one into +10. Here, 7 and 5, I could make into 35 because that's the least common multiple. I could have done either one. I chose, in my example here, to eliminate the y's by making them both have coefficients that are opposites. So I said, okay, if I want this to be 35, I need to multiply this by 7. I'm going to multiply both sides of that equation by 7. I want to make the bottom equation have a -35 in front of the y. So I would multiply it by +5. So I multiply both sides. So I distribute this, and these are my two equations that I get. So you can see I get 14x plus 35y equals 28, 25x minus 35y equals -145. When I add these two, the y's cancel out because they add up to 0 now. So I have x's equal this number, divide, x equals -3. Okay. Notice that to do substitution, you have to have your equations set up so that they match up. X's, y's equals the number. So if it's not like that to begin with and you want to do elimination, move things around. You can use substitution or elimination for any system of equations. It's totally up to you. Okay, mathematically you can do it either way. Sometimes one's just easier than the other because of how it's set up. Just like before, I have my x, I plug it into either equation. I chose to do the top equation, gives me a y. Again, we want to check these in both equations. Okay. Now, if I had wanted to eliminate the x's instead, they both have to be 10, but one has to be positive and one has to be negative. It doesn't matter which one. So, for example, I could have multiplied the top equation by -5 and the bottom one by +2. I would have ended up with a -10x on top and a +10x on the bottom. So you might want to do it that way just as practice to make sure you get the same answers. Okay. Then we get into a whole bunch of word problems. And there are some good video lessons that came with Lumen there that are online. So those are in the section of applications or word problems. They talk about using a chart method, which I did in some of these, and we'll talk about it. But you have to understand there's a lot of different kinds of equations here of kind of different word problems, and you have to figure out how to know how to set them all up. You do also have to write either an equation or a system of equations for each one of these. You can't just guess and check. So some of these you can do with one equation, some with two, some with either, depending on how we set it up. So let's just first look at this consecutive integer problem. And in Math 95, you would have done some of these, so hopefully it's a little bit familiar either from there or from another previous class. Consecutive integers means integers, numbers right in a row. So if I'm at any number at all on the number line, to get to the next number, I would add 1. And then to get to the next number, I would add 2. If I have consecutive even integers, if I'm on any number on a number line, to get to the next even number, I want to add 2. So if I'm at some number here and I'm saying this number is even, well then I know that the next number is going to be odd. Okay, if I'm at an even number here, the next number has to be odd. That's how our numbers work. So if this is x, I'm going to add 2 to get to the next even number. And then I'll add 2 more, or x plus 4, to get to the next even number. Okay. Most people kind of understand that pretty well. The one we have to watch out for is the other situation. So let's say I still have an even number, an odd number, even, odd. Let's say this is my x now, this odd number, okay? Well, how do I get to my next odd number? This is x plus 1. I add one number to get here. Say this is 15, this is going to be 16, right? But this is even, so I have to add another one to get to my odd number. And this bothers people sometimes because they say, well, 2 is even, which it is. But in this case, the 2 here has nothing to do with what the value of your number is. It just has to do with how I got from one odd number to the next odd number. I added 2 to skip over that even one in the middle. Okay, so for example, this one says find 3 consecutive even integers whose sum is 540. So there's a lot of information in there. I want 3 even numbers right in a row. So if x is my first one, x plus 2 is the next even number, and x plus 4 is the following even number. Okay. Their sum is 540. Sum means they add up to 540, right? Sum is the answer you get when you add. So here's my equation I'm writing. I just have one equation now because I only used one variable in this example. So I add up the x's, I add up the numbers, simplify, solve for that just like you would normally. This again is very much review how to solve that. Now don't forget that we're trying to find all 3 numbers. So 178 is my first number, my x. I add 2 to get to the next even number. I add 2 more to get to the next even number. To check this, you want to check, do I have 3 consecutive even integers, not decimals, and do they add up to 540? If you end up with a decimal here, it means you did something wrong over here and you had to divide by the wrong number. Okay, I am almost at the time limit for this video, so I'm going to stop in just a minute. I will do another video. Again, I'm not going to go through every bit of every one of these examples, but we will kind of spot check, go over some of them and some important things about them, and then I'm happy to go over any of them in Zoom or just one-on-one, but that way the videos aren't just hours long. Okay, so I'll be back with more in just a minute.